In this video, I'll be solving the ALEKS problem called predicting the single bonded molecular compounds formed by two elements. The first thing that we have to do for each pair of elements is determine whether or not the pair is going to form a molecular compound. Molecular compounds are formed between two nonmetals. So in order to form a molecular compound, the two elements both need to be nonmetals. ALEKS's periodic table is really handy for classifying elements as metals or nonmetals because it has really good color coding. ALEKS's periodic table is located on that button right there. So for my first pair, I have carbon, which is right here, and I have fluorine, which is right here. They're both yellow, which means that they are both nonmetals, and that means that yes, this particular pair of compounds particular pair of elements will form a molecular compound. And once we've decided that they will form a molecular compound, we have to come up with their formula. And to do that, I think it's really helpful for us to think about the Lewis dot structures for different elements. I'm going to draw all of the relevant ones out for this problem. There's hydrogen with its single electron. Next, we have carbon. Carbon has 4 valence electrons, so its Lewis dot symbol looks like that. Nitrogen has 5 valence electrons, so there's its Lewis dot symbol. Next, we have oxygen with 6 valence electrons. So its Lewis dot symbol looks like that. And I'm actually just going across the periodic table. And then last, we have fluorine, 7 valence electrons. So it'll have 7 dots in its Lewis dot symbol. So to come up with the chemical formula for a pair of elements, what we're going to do is take their Lewis dot symbols. I have carbon. I'm just going to copy it down here. And then I also have fluorine. I'm going to copy this as well. Somewhere in this problem, it tells us that all of the bonds, where does it tell us? All of the bonds are single bonds in these compounds. Here it is. Assume that all the chemical bonds are single bonds, not double or triple bonds. That's going to make this problem really easy. So what we're going to do is take the Lewis dot structures of our two elements. Everywhere that you have a single electron, you are going to need to pair that single electron up with a single electron from one of the other types of elements. So if I have a single electron on the carbon, I need to pair it up with a single electron on the fluorine, and we're going to do that just with a bond. And I have another single electron on the carbon, and that just simply means that I need another fluorine. Oh, I just really stole my fluorine from myself, so I put that fluorine back. And I need, as I said, since I have another single electron on the carbon, I'm going to need another fluorine. Stick it right there. And we're going to form another bond in between the carbon and the fluorine. That's really ugly, but that's okay. I've got 2 more single or unpaired electrons on the carbon, which means that I'm going to need 2 more of these fluorines. So let me get another one right here. I'm actually just going to turn it upside down so that I can line it up a little better. And I am really running out of room for this really ugly Lewis structure. So I'm going to stick another fluorine right there, and we're going to form another bond between those unpaired electrons. It doesn't matter that this is an ugly Lewis structure because we're only using this as a way of counting the number of atoms that are necessary to form a molecular compound. We need 1 carbon atom and we need 4 fluorine atoms, and that chemical formula is CF4. If you're a little bit stressed out about the order of the elements in this formula, like should it be CF4 or should it be F4C, one of the things that I've noticed with this ALEKS problem is that they list the first element first and they list the second element second, with one exception, which I am going to describe. There is one exception, but for almost everything, first element that it lists is going to be the first element in the formula. Second element is going to be the second element in the formula. Last but not least, we need to give this guy a name. To name it, we're going to be using just the standard nomenclature for molecular compounds or compounds formed between nonmetals. So we're going to say the name of each element individually in order. So starting with the first element, which is carbon, and then for the second element, we have fluorine. Because it's the second element, we're going to drop the "ene." So instead of fluorine, we are going to drop the "ene" off of the atom's name, and we're going to change it to "ide." And we also need to indicate that there are 4 of those fluorines, and we're going to do that with a prefix in front of the fluoride. The prefix for 4 is tetra. So I'm just going to kind of erase all this and write it a little bit neater. Tetrafluoride. And prefixes, if there's only one, the prefix is mono. If there's two, the prefix is di. If there's three, it is tri. If there's four, it is tetra. You're not going to see anything bigger than that. We don't use the prefix mono for the first element in the molecule's name. So we don't say monocarbon tetrafluoride. We only use the mono prefix for the second element. All right, let's try our next pair. We have hydrogen and bromine. First thing we need to do is determine whether or not they're going to form a molecular compound. Hydrogen is a nonmetal, bromine is a nonmetal. That means yes, they are going to form a molecular compound, and we have to come up with their formula. So what we're going to do is get the Lewis structures, the Lewis dot symbols for those two elements. We have hydrogen and we have bromine. I didn't give you the Lewis dot symbol of bromine, but here's a trick. For any element, there's bromine right there on the periodic table, its Lewis dot symbol is going to match that Lewis dot symbol of the element at the top of its column. So fluorine, chlorine, bromine, iodine, they all have the exact same Lewis dot symbol. Same is true over here. Sulfur has the exact same Lewis dot symbol as oxygen. Phosphorus has the exact same Lewis dot symbol as nitrogen. So for what I can do is just change my fluorine into a bromine, and that is still a valid Lewis dot structure. Lewis dot symbol. I keep mixing that up. Okay, so for every element or for every electron that is unpaired, we need to match it up with an unpaired electron from the other atom. Boom, there we go. That's it. That takes care of all of them. That is HBr. And this molecule's name is hydrogen. Don't forget to change the ending from bromine to bromide. So here is a violator of the prefix rules. If you have a compound where the first element is hydrogen and the second one is a halogen, so that's going to be HBr as well as HCl or HF. Mono prefix is not used at all. That's really unpleasant. There's a lot of really weird rules that are really hard to keep track of. Just make good notes for yourself and consult your notes before you name anything, just to make sure that it's not one of those weird rule violators. Okay, last one, we have lithium and chlorine. Lithium is located right here on the periodic table. That is a metal. That means it is not possible for this to be a compound formed between two nonmetals, and that means I'm not going to check this box. It will not form a molecular compound. Since it's not forming a molecular compound, I cannot come up with a formula or a name. So I'm done with that. And when I flipped through a lot of variations for this ALEKS problem, what I did notice was that there were going to be two. For every example that I saw, there were going to be two molecular compounds, and there was going to be one pair that did not form a molecular compound. So you should expect to see that pair not forming a molecular compound. Now, I did tell you there was a weird exception. There was one weird exception where the first element that ALEKS provided was not the first element of the formula. That weird exception is water. So hydrogen, when I saw this ALEKS problem, it listed oxygen first, and then it listed hydrogen as the second element, and those two come together to make H2O, and it is convention that we list hydrogen first in the formula and oxygen second. So that's going to be one exception to the little trick that the first element provided to you is the first element of the formula. This molecule, ALEKS wants you to name it as water. It does not want you to name it using standard naming rules, which would be dihydrogen monoxide. It wants you specifically to say water. Another example of a compound where ALEKS wants you to use its common name is going to be NH3. If you get NH3, that molecule, ALEKS wants it to be called ammonia, which is its common name, does not want you to call it nitrogen trihydride. So look out for those two exceptions.